Yesterday in class we talked about permutations, and when we are looking at things where order is important, we use a permutation like standing in line, forming a word, forming a number, things like that. We also talked about that we can't use a permutation when there's a restriction. Restrictions are, for example, if we were forming a word and we had to have the letter E come first, or if we're forming a number that has to be less than 100. Things like that where there's restrictions placed on what you're looking for, we can't use a permutation because permutation gives you all the different outcomes that are out there. Well, what happens when we are looking for something that deals with order, so we're using a permutation, but we have repeated things to look from? Well, that's called repetition, and that's what we're going to deal with today, is when we're using a permutation with repeaters. So basically, it is n factorial over r factorial, or what you're used to seeing is a permutation. So let's take a look at this very last formula. It's a permutation of n things taken r at a time over each repeater as a factorial in the denominator. Well, that's kind of a little hard to understand just looking at the formula. So the best way to do that is to take a look at an example. So let's go right to example number 1. You're going to need your calculator, so if you don't have it, you may want to pause the video, go get your calculator, and come back. All right, with number 1, it says how many different 3-letter words can be formed from the letters in mom? Well, we're forming a word, so it's a permutation because order is important. Mom has 3 letters in it, so it's a permutation of 3 things taken 3 at a time. Now, that's something that we already know how to do. What's new now is mom has 2 letters that repeat. The M repeats twice, so the M is going to get its own factorial as a denominator, and there's 2 of them, so it's 2 factorial. Now, what's another way I can write this? Well, when your n and your r value are exactly the same, you can write this as just a plain old factorial on the top. So really, you can write it as 3 factorial over 2 factorial. Either way is acceptable. But again, the only way you can rewrite the top as a factorial is when the n and the r of your permutation are exactly the same. All right, so let's take out our calculators and put it in. Either one you put into the calculator will come out to be the exact same answer. So give yourself a minute. You might want to pause the video and put it into the calculator. Okay, hopefully you ended up with 3. If you didn't, remember you have to put in the number first and then math, scroll over to the right to probability, and then if you're choosing factorial, it's number 4. If you're choosing permutation, it's number 2. Okay, let's go on to example number 2. In example number 2, it says how many 7-letter words can be formed in the word divided? Well, let's count up the letters and divide it. There are 7 letters. It is definitely forming a word, so order is important, so it's a permutation. It's a permutation of 7 things taken 7 at a time over, let's see, we have a few repeaters there. D repeats 3 times, so he's going to have his own factorial. I repeats twice, so he's going to have his own factorial. Anything else repeat? No. Well, another way I can write the numerator would be 7 factorial over 3 factorial times 2 factorial. Now, here's a little bit of a difference with this one than you saw in number 1. The bottom has 2 factorials, so you have to make sure that you encase your denominator in a set of parentheses, because if you don't, this numerator is not going to be divided by the entire denominator. So you're going to take out your calculators, and I'll walk you through this one. We're going to go 7, math, scroll over to PRB, number 4 for factorial, divided by, parentheses, 3, math, scroll over to PRB, number 4 for factorial, 2, math, scroll over to PRB, number 4 for factorial, close the parentheses, hit enter, and hopefully you ended up with 420. All right, let's go on to example number 3. Example number 3 says in a bin, Jeff has 16 baseballs, 5 footballs, and 10 basketballs. And how many different ways, symbolically, can he pick up 1 ball at a time? Well, if you're picking up 1 ball at a time, whatever you're picking up first versus second, third, order is important. So it's definitely a permutation. How many objects am I picking up? If I 16 and 5 and 10, if I add that together, I have 31. So it's a permutation of 31 things taken 31 at a time, or I can just write it as plain old 31 factorial. What repeats? Well, the baseballs repeat 16 times. The footballs repeat 5 times. And the basketballs repeat 10 times. Now, it told me to do this symbolically. So basically, I don't need the answer. I just had to write it out symbolically. Another way this could have been written was permutation of 31 things taken 31 at a time over 16 factorial, 5 factorial, 10 factorial. So if this was multiple choice question, either of those could be a choice, which would be the correct choice. Remember, if you were going to put this in the calculator, you'd have to encase your whole denominator in a set of parentheses. But that's all we have to do with this question because, again, they said symbolically. All right, let's go on and see what we have to do. Now we're going to talk about what's called combinations. Now, I'm sure you're used to hearing combinations like your combination lock on your locker. And when you do your combination lock on your locker, order's important. Well, combination lock really should have been called a permutation lock, because that's when order is important. When we talk about combinations in mathematics, combinations means order is not important. Okay? So what does that mean? Well, when is order not important? Well, order is not important when you form a group or a team or a committee, anything like that. And the reason it's not important is because it doesn't make a difference who they pick first or second or third to be on a team. You're all on the team. So order isn't important. Now, combinations is the exact same. Well, it's very similar to permutations as far as putting it in the calculator. You put the first number in first. You then hit math, scroll over to PRB. But now you're going to go to number 3 for combinations, and then you put the second number in and then hit enter. But when you're doing a combination, just like a permutation, your n value has to be greater than or equal to your r value. So you have to make sure that your n value is either bigger or equal to your r value. All right, here's the formula doing it by hand, but I'm sure you don't want to do it by hand. You'd probably want to put it in the calculator. So let's take a look at number 1. Combination of 5 things taken 3 at a time. So clear your calculator. You're going to push in 5, math, scroll over to PRB, number 3 for combinations, 3, and then enter. Hopefully you ended up with 10, just like I did. All right, let's take a look at example number 2 here. Example number 2 says all of the following are equivalent to 12, or a combination of 12 things taken 8 at a time, except, all right, so we have to figure out which one doesn't equal that amount. Well, what we should do is find out what that equals. Well, when I put it in the calculator, so we're going to clear our screen and we're going to go 12, math, scroll over to PRB, number 3, and then 8, enter, and you should have ended up just what I ended up with, 495. So I want to know which one of the following does not equal 495. I strongly suggest when you put these in the calculator, when you have many things in a numerator or a denominator, you need to encase it in a set of parentheses. So like for number 1, you should probably put the numerator in parentheses. Same thing with number 3. And then the number 4, you should probably put the denominator in parentheses. So I want you to pause the video, and I want you to put each one into the calculator one at a time and get a value, and find out which one does not equal 495. And then come back and check and see what I got. All right, so hopefully you realize that when you did this, you ended up with 495 for number 1, so you wouldn't have chose that one. Number 2 was also 495. Number 3, I think, was a long number or a decimal, so I made it a fraction. It was 33 over 112, which is not 495. And the last one was also 495. So my answer would have been choice 3, because that is the one that does not equal a combination of 12 things taken 8 at a time. All right, let's go on to example number 3. Watch for keywords that indicate combinations such as clubs, groups, committees, teams, and etc. All right, a coach must choose 5 starters from a team of 12 players. How many different ways can the coach choose the starters? Well, he's choosing starters from a team. Remember, if you're choosing starters, everybody he chooses is going to be a starter. So order's not important because they're all starters. So it's a combination, okay? It's a combination of how many players does he have altogether? 12. How many starters does he want to choose? He wants to choose 5. So we're going to put that in the calculator, 12, math, scroll over to PRB. We're going to actually choose, if I can remember, let's see, which one is it? Choose number 3 for combinations, and then 5, enter, and hopefully you ended up with 792. So think about that. Out of 12 players, how many different ways can he choose starters? Oh my gosh, that's phenomenal. All right, let's take a look at number 4. And how many ways can he select a committee of 2 people from a group of 7 people? Oh, committee, order's not important, so it's a combination. It's a combination of, we're taking 2 people from 7, so 7, 2, so it's a combination of 7 things taken 2 at a time. Plug that in the calculator and see what you get. And hopefully you ended up with 21, just like I did. All right, let's go on to the other example. Example number 5 says, there are 14 juniors and 23 seniors in the service club. The club is to send 4 representatives to the state conference. Okay, how many different ways are there to select a group of 4 students to attend the conference? Well, group is a combination because order is not important. Well, how many kids am I allowed to select from? So here's my combination. Let's see, I have 14 juniors and I have 23 seniors, so I have 37 total. All right, so I have 37, so it's a combination of 37 things taken, and how many do I want to select for? Okay, so put that in the calculator. Let's see what you got. All right, hopefully you ended up with 66,045. All right, part B. If the members of the club decide to send 2 juniors and 2 seniors, how many different groupings are possible? Now there's some specifications on what they want to send, okay? So I need 2 juniors, and 2 seniors. So basically I'm looking to send a specific amount of juniors and a specific amount of seniors. Please remember, in probability, the word and means to, you're right, it means to multiply. So, how many juniors do I have? 14. And it doesn't matter which junior I pick first or second because I'm just picking them to form a group. So it's a combination of 14 things taken 2 at a time. And means to multiply. A combination of, how many seniors do I have? I have 23 and I'm taking 2 at a time. All right, I'm going to need to put that in the calculator. And you can put that in the calculator all at one time. So here we go. 14, math, scroll over to PRB. We're going to choose number 3 for combinations, 2, times 23, math, scroll over to PRB. Number 3 for combinations, 2, enter. Hopefully you ended up with 23,023. So again, in this case, letter B, we actually had to write out, it was kind of like a restriction, but it was more of a combination restriction because we still were using all the juniors and all the seniors. We just wanted a certain amount of each. So we actually had to separate it by the word and. All right, I'd like you to read B, the review on permutations and combinations, and complete examples A and B on the bottom, and bring that to class with you tomorrow. If you have any questions, please make sure you jot them down so that you ask them in class before we start working on our worksheet. Have a good evening.